Hello, and today's agenda is this one. Is the next one, which is called the print number of tables. This one basically, it took me a long time to understand this. To be honest, it has a lot of components in order to, if you wanted to get into it. So it's quite a night already. I wanted to make it finish quick, but it has a lot of components, as I told. Basically, so today I have my mouse, I can use it. So basically what it has, I have gone to several of these example documentations, and the documentations which are written here, the official documentation. But if you go there, and you're basically going to find p3 pages there, and no idea what that is. So much information is there. Everything is a little clotted. You don't understand most of the parts, which are what are they talking about, and neither do I, to be honest. It took me a lot of time to understand it. If you go to the documentation, and there should be a documentation of, not SQL language, there should be a documentation about SQLite. I think there is a structural guide of it, to be honest. I did found it. I was reading about it. Uh, Obsolete documents isn't. So there is a lot of things are there. This one is the one, I think. Yup. This picture, oh boy, this picture took me a long time to understand. I wanted to give you a overview of what this is, and this is really cool and depressing at the same time, to be honest. So basically, what happened when the SQLite is built, getting built. So it was a small, lightweight, things we all know, small, lightweight, fast, whatever the thing is. The reason why it is fast is lightweight, should be lightweight, and it's fast. There is a big reason why that is. If you go into these things, you're not going to get it easily. But I'm going to give you a brief architecture overview of why that is, how that is done, and something like that. So basically, this part, or the this part is called the front end of, you can call it a front end. Shouldn't be called front end, but yeah, why not? Basically, the SQL parsing part, SQL compiler. If you ever worked with any kind of a compiler, you know about this part. Like, why I'm talking about this part is because this is basically working with the more like on a getting the byte code kind of a thing. So what we do, what we did previously, what we did, we come from something like a sql query sql query, and we come to a conclusion from it to the db file. Now we have to understand the db file in general. So what it does, high level what it does, it creates an interface. I have no idea what interface is, but assume something is there. Basically we get the SQL command and processor, it tokenizes it, parses it, and generates a code generator, which is basically a bytecode generator. That bytecode goes to virtual machine. As we know, if you ever worked with a compiler, you know what tokenizer is. In small language, I'm in small sentence, I'm going to say, let's say there's a command called select star from users. So what are going to be the token? So select is a token, let's say. From is a token. You can think of like the star is a token. So these are tokens, and you like divides everything in a large switch case, and you get the data. This is basically it. It does that. Parsing does all the logic of like trying to understand what the code says, and the code generator are basically generate the byte code for it, give it to the virtual machine. The virtual machine are going to do the every work that he needs to do. Backend of it works something differently. I'm not going to go really deep into b trees and this kind of a thing, also in pager. But think of it like this: B tree is basically just the index of it, like finds the index, does the job, and creates a pager. Not creates a pager, like helps the pager. The pager actually uh, update or changes the DB value, and the OS interface is basically nothing but like, what is your OS? It is Linux, or let's say Windows or Apple, whatever that is. So that thing can be determined from OS interfaces. Accessories we are not going to talk about. Mostly B trees are going to be something like the it is going to help you to find the documents. As B tree have a logic. Okay, you don't understand B tree that well directly. It has a logic. You need to understand how B trees work. So it has a leaf node. So the leaf node has the all the table contents or the table indexes that going to be that goes to pager. Pager finds it, or pager does all the job. So pager has the particular task to do all the job. Think of it like getting the value from something. So this is the whole work which is which are going under the hood of SQLite. To be honest, this gave me a lot of trauma, but understood particular fact after a lot of deep diving of how to solve today's challenge is in this file. It's not like here any of the file it has anything, nothing to do with it. A little bit of uh, this file also does the work. This is the official file. uh, does the work a little bit. I gave this one the first read. After that I search for better ones, but you will not going to learn most of the things here. It does have a good documentation if you wanted to like sort of reference it, but other than this I don't think so. It's pretty complicated to understand from it. But if you scroll down a little bit, a lot, you're going to find something called this link. You're going to open this one, this particular thing. What is this? What is happening on this particular thing? This is an internal architecture of a .db file. We are working on what? We are working on the .db file, right? So this particular thing is basically the internals of the DB file. From this, you definitely know this. If you zoom in a little bit, you definitely knew this part. We have already done in the first video that it starts with SQLite format 3. It has 16 bytes, so it is just like moving to 16 bytes, as you understand. 16 byte has the this 16 byte, or the 16 to 18, stores the 16 and 17 stores the value of the page size. Okay, we already did this particular thing in the previous video. The interesting part is that we have to understand how SQLite stores data in the .db file. How SQLite stores data in the db file, or .db file to be precise. So this particular thing happens in both ways. When I was learning about databases, while I was doing it, learning about it, to be honest. So there is a thing called views are actually popular. There is a thing called indexing are actually popular. So when you think about these particular things, have you ever thought how they are going to be stored? As you know, in views, if you guys don't know about it, this is basically you store a query. Okay, think of it like this: you store a query, and you store a query to a variable, and you give the variable to somebody else. A common definition you might heard about views, which is virtual table. So you have to store something in that virtual table, right? So this particular thing has been done by something called SQLite schema. What is this? I'm going to come in later, but you're going to find this particular name right here to SQLite schema page. SQLite schema internal is a internal DB file, or internal cell. You can think about it. It is an internal cell or internal table, be a good word. Table, an internal table is SQLite schema, in which you're going to find some things called views and that kind of stuff. So views, indexing, the number of tables, that kind of stuff are going to be stored in where? In the SQLite schema internal table. Next thing you have to figure it out is how can I find the table size? What is the table size going to be? Mostly what I heard is that table size is basically like this is the leaf table. Okay, so in SQLite we store this as the first. So the page number is stored and then the table number. Okay, so the table number is stored as 1. So if you think of 100 is right now, you can think of it like this. Basically what happens, if there is a root node called SQLite schema. So the leaf node is being started from 100. You can think of it like a eternal truth. So the leaf node, so this is the leaf node, and this leaf node is getting started from what, 100 of bytes. So it gets started from 100 bytes. Okay, so this particular thing, what it does, this 100 bytes, okay, As you see, it has written here. In when we are doing the SQLite schema, we are learning about the SQLite schema table. It has, think of it as the command or a header, which is called the SQLite format 3, and then there is a null character, right? In 100, the hundredth byte, you're going to find there's a also a comment kind of a thing which is called the leave table. Got it? After this, we saw the page size. So you're kindly leaving it right now. You don't have a page size as it is the part of the one page. If it is a part of the another page, you're going to see more of it. This is not part of the multiple pages. This is part of the single page. So we are making it 0. After that, there's a number of tables are there. So there is the number of tables is 1. You can switch to any other things. Uh, so there is a lot of stuff here. Okay, right here it is stored in a different way. Okay, it could be different. Okay. So basically, what is the thing I wanted to talk about? This probably could be there are multiple pages, but there should be multiple tables too. So mostly what is the case? The case is here. You're going to have this particular thing at the third of it, third part of it. Okay. So in the hundredth table, it has two more part of it. So this one, the 103, has two more bytes to go. This two more buffer is what is the number of tables are there. So if we come back to the code now, and I'm going to make it a little bit bigger. I'm going to make this one is also bigger. Let's try to write it in my code first, or should I write it here? Write it here, let's say. So there is a buffer. I called it buffer, but I can call like page size buffer would be a better one, as I'm using here page size buffer, page size buffer. So I need to find, right now we found the page size, we need to find the table size. The table finding the table page size or the table size. Uh, I wanted to sleep so bad, by it's 2:31. How many minutes of recording? 19. Pretty low, to be honest. Tomorrow I uploaded a video of 60 minutes. God damn. Let's see. I have to find it, so I need to do an fseek again. I have to go to the 100 and 3. So if I type 103, we have went to this particular place right now. Now I have to store these in a buffer called, like, you can call it unsigned char. What can I call it? Good one. Table size buffer. This is going to store, let's say, 3 or 2. 3 would be a better one. Is it? Okay, let's assume 2 for now. Same logic. If read table size buffer size of char 2 db file unsigned short table size equal to table size buffer of 1 table size buffer of 0 is less than 8. So after run it, how can I run it? Make build. Okay, there's a command which is undeclared. So this one shouldn't be command, this one should be cmd compiled. We have to go to the bin and msql. After that, I need to give something called, what do I need to give? What is the command? I already forgot. Something like superheroes db of .db info. Two. So it did find something, right? So the database page size has also been showing here, but the question is, I could be wrong every time, so I'm going to copy this particular part and I can copy this particular part entirely and copy it, paste it right here. I definitely need a linter for sure. Git at git at dot git commit. Let's see if it passed the test cases or not. Okay, the build failed here, which is a db file. uh, I need to change the naming conventions right here. To be honest, I can just copy paste it. Before pushing, I wanted to see what is the output they want. So this is the output they want. So they want this part to be this and this part to be this, otherwise the database will not going to run. Okay, let's test it again. So the test cases are passed. We passed it, guys. Passed it. So the table names are also been written in the after the 2000 4054 4054 was table 1, leaf table. So serious 4500 table is one of the one, that's for sure. Or the 74. It would be better if they had more examples. They do give good examples, to be honest. I have to find the table word, then I can say ki like, yeah, I have found it, something like this. So I have to run a more like a while loop, something kind of a thing, until unless I find something called table at first. I can fseek that part too, but yeah, it's pretty hectic. It should be after 100, that's for sure. This is a hex dump one. I also tried hex dump, got out of it immediately. Okay, I'm going to record this much part only for this video. I'm going to cover the next part on the next video.